Hey guys, welcome back. So in the last video, took a look at doing the Project Euler stuff in Rust. Figured I might try to do a few more. We'll take a look at the second one. Actually, you know what? Let's take a look at the third one, um, because I believe I have to use floats for that. And that's going to be a little bit more interesting because I'm going to have to import a library. Now, it's part of the standard library, so it's not going to be a big deal. But it's going to take it's going to have us do something that in JavaScript we don't have to do because JavaScript, it's just everything is just there for you to use. Let's say cargo new Euler. What's that? Largest prime. Just for quick reference, we need to find the largest prime factor of that number. So let's take a look. And let's see. We had a few solutions. No, we only had one solution for the JavaScript one. This one was kind of complicated. Yeah. Okay. This is gonna be fun. Yeah. So this was complicated. So what we did was we started out with the numbers, 6 million or 600 billion or whatever. Obviously, that's not what I passed in here when I was testing it to make sure it works for others. What number is this? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 600 billion. Okay, so we passed in a number around 600 billion. For any number, we're going to check to see if it's divisible by 2. And if it is, we keep on dividing it by 2 until it is no longer divisible by 2. And we set the last factor to 2. Okay. And then we initialize the factors that we're going to go ahead and check. We didn't exactly optimize this because we only need to be checking through primes. I didn't bother generating a list of primes. Frankly, I don't think it matters all that much. And then as long as upper bound is not 0 and the factor is less than or equal to the max factor, which gets recomputed right here, we're going to keep on going. And then we check to see if this upper limit, the 600 billion divided by whatever, at whatever point, if it's evenly divisible by this number, then we divide the upper bound, the limit, by that factor, and then we set that the last factor to we set it to divide it. So like in the case of, what is it? It's 3 times 17. Not 49. 3 times 17 is 51. Yeah, so when you're going through this, for example, with 51, it's going to divide out 3, and upper bound is going to be set to 17 now. And the last factor is going to be set to 3. It's not going to go through this while loop because it's only divisible by 3 once. And then the max factor is going to be recomputed to be the square root of 17, which is somewhere just above 4. And factor is going to get increased to 5. We're going to exit immediately with upper bound being equal to 17 and the factor being equal to 5 and the last factor being equal to 3. And then we're going to return upper bound does not equal 1, so we won't be returning last factor. We'll be returning upper bound, which is 17. Okay, perfect. Now that we remember that, we can go ahead and get cracking. Can't use 32 for this. That's, I think, somewhere in the hundreds of millions is the limit for that. And we can use smaller for this. I don't mix and match number types. I guess you can. Not something that I'm too too keen on doing if I can avoid it. And luckily this is small enough. And the memory capacity doesn't matter. That I can just move on. Okay, so big difference with JavaScript. There's no parentheses here, which is great because I always forget to put the parentheses in JavaScript. Yeah, it's going to tell me that. Yeah. Okay. Okay, so now we've got to use the square root. The float library has a square root. I don't think that any of the others do. I think it also has. Oh, well, we're going to read this as a as an unsigned integer anyway. So here's what we're doing. Root. Okay. So square root comes from this library. It needs to be a float in order to do that. So we take this number and we say, yeah, you're gonna be a float instead. Um, to get the square root. After that, we're going to read it back as an unsigned integer, 64 bits, and then we're going to add 1. Reading it as an unsigned integer is going to round down. That's just how the computer works. It doesn't round to the nearest, just rounds down. And then it's going to add 1. We don't necessarily need to do the add 1. We'll make where we have things that are less than, make it less than or equal to. But we have to do one or the other. We're going to do it this way. Let's say while number is greater than 0 and dir is less than max factor. If num yeah, I know it's telling me it doesn't need to be mutable. And then it's equal to 0. And then factor factor. And then we need to do and then we need to recompute the max factor. Equals okay. We're slowly getting the computer to stop yelling at us for declaring things as mutes. And then we've got this other problem of it telling us. And then we need to iterate the factor to. Is that where we put it? No. That's too far. Okay. And then we can now in the other one with the JavaScript, we used the ternary operator. Rust doesn't really have a ternary operator, but it has its if statements approximate using a ternary operator. Else. So this is going to do the same thing as a ternary operator. You can even set a variable to be equal to this. Like I could say res equals if whatever else whatever, and it's going to work. Um, that's something that you can't do in JavaScript, because to do something like that in JavaScript, uh, you use ternaries. Let's go ahead and see if we can get this running. Is that the right answer? Indeed, it is. Just like in the last one, if you want, you can toss this into, or you can toss in some input outputs. It's up to you. It's easy enough to do, obviously. It adds a little bit of flair, a little bit of practice if you're just learning how it gets you more comfortable with the input output stuff. But yeah, the big sort of thing with this that we didn't have to worry about in JavaScript is floats are a different number type than integers. JavaScript just has the standard double precision float. And because that, we've got to go back and forth from reading something as a float in an unsigned, primarily to be able to do the square root, because the square root function is a part of the float library. As far as I've seen, it's not part of the integer, any of the integer libraries. If I'm mistaken on that, you guys are welcome to correct me. I've known Rust all of 2 weeks now, so very possible that I could be wrong. Hope you guys enjoyed the video. As always, drop likes, hit subscribes, etc., etc. I will see you guys later.